Hello, ladies and gentlemen, and welcome back. Today is Monday, April 20th, and our focus this week is going to be on theoretical probability. Last week we learned all about experimental. So this week we're going to learn about and explore what theoretical means. So let's take a look here. Sometimes you can find the probability of an event through reasoning about the outcomes in the sample space. A probability that is found this way is a theoretical probability. So again, we're going to look at the sample space to figure out what our theoretical probability is. We are not rolling any dice. We are not flipping any coins. We are not spinning spinners. We're just looking at the coin, the die, or the spinner to help us answer our questions. When all outcomes of an action are equally likely, you can use the theoretical probability formula. And so our formula here is the probability of whatever the event is the number of favorable outcomes divided by the number of possible outcomes. Favorable outcomes are the outcomes in the sample space that is satisfying the event. So let me show you a few examples of what I'm talking about. In my first question here, it wants to know what is the theoretical probability of rolling the following. So you'll see here I have a standard number cube, 1, 2, 3, 4, 5, and 6. And it wants to know what is the theoretical probability of rolling the number 6. Well, think about it. How many 6s do you have on a number cube? There's only one. So that is your numerator. The 1 is your number of favorable outcomes. And how many possible outcomes do we have? Well, a cube has 6 sides, so there's 6 possible outcomes. So the probability, the theoretical probability of rolling a 6 is 1 out of 6. So now let's go ahead and look at our next one, the probability of rolling the number 4. So again, think about our number cube. How many number 4s do we have on our number cube? There's only one number 4. And how many possible outcomes are there? And we have a number cube. Standard number cube has 6 sides. So again, we have the theoretical probability is 1/6. Now, when we move on, it says an even number. So again, think about your number cube. All the numbers on your number cube are 1, 2, 3, 4, 5, and 6. So we want to think about what's the probability of rolling an even number. So our even numbers are 2, 4, and 6. So 2, 4, and 6, that's 3 even numbers. We have 6 sides to our cube, so that's a 3 out of 6, and we can reduce that down to 1/2. Now remember, we can always convert these into decimals and into percents also. Our 1/2 we know is 0.5 and 50%. So let me just come back here to rolling a 6 and rolling a 4. Those were both exactly the same, so we'll just do this once. And we have 1/6, and there's our decimal equivalents. If I ask you to round that to the nearest hundredth, that would be 17 hundredths, which is about 17%. Okay? And so our last one here is what is the probability of rolling a number that is greater than 4? So the numbers that are greater than 4 are 5 and 6. So that's 2 possible numbers greater than 4 out of 6. Simplify that fraction, that is 1/3. Our decimal equivalence of this, remember, is 0.3 repeating. And if I asked you to round that to the nearest percent, we could examine that or say that that is 33%. Okay? So that's a number cube. Let's go ahead and look at spinning a colored spinner. So again, we are talking about theoretical probability. And they want to know what is the probability of spinning a red. So looking at your spinner, how many reds do we see? There's only one. That is your number of favorable outcomes. And your denominator is the number of possible outcomes. And so we have 1, 2, 3, 4 possible outcomes. So the probability of spinning red, the theoretical probability, is 1/4, 25 hundredths, or 25%. And we'll do the same with green. So if I see here, I have 1 green, we have 4 possible outcomes, so we have the same exact answer. Now, when we read this next one, it says blue or orange. I have a blue and I have an orange. Blue or orange. So it could land on blue, it could land on orange. So the number of favorable outcomes that I could have is 2 out of 4. We simplify that down to 1/2, which is 0.5 or 50%. Now, in the last one with my spinner here, it says blue and green. Blue and green. Can I land on both blue and green at the same time? The answer to that question is no. I cannot land on both blue and green at the same time. So favorable outcomes is 0 out of 4. So that's going to give us a 0% chance. Okay, so now we'll just look at a bag of marbles. And we want to know what is the theoretical probability of choosing a red. So when I look at my marbles, I have 1, 2, 3, 4, 5, 6, 7 reds. And it wants to know the number of possible outcomes. So I need to count all the marbles that I have in my jar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we have 20 marbles in our jar. And again, we practice turning that into a fraction, which it is, into a decimal, which is 35 hundredths, and as a percent, which is 35%. My next question is asking me to turn it into, or find the theoretical probability of choosing a yellow. When I look in that jar of marbles, there aren't any yellows whatsoever in there. So that's going to be our 0 out of 20, or 0%. And now we can go ahead and count our greens. We know that the number of possible outcomes is 20. So now all I have to do is count green. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is 10 out of 20. Reduce that fraction to 1/2, 5/10, or 50%. And then it says blue or red. Well, I just counted the greens and there were 10. So if you think about it, how many blue or reds should we have left inside that jar? Well, we have 20 in the jar, and I'm hoping that there's 10 blue or reds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so that gives me my 1/2, my 5/10, or my 50%. So ladies and gentlemen, what you are going to do today is you are going to be working on IXL DD4. And I know we had some trouble last week with some of our IXLs, so I'm going to disconnect my hover cam, and hopefully we can, I can get you on my computer here. So let me disconnect. You might see me for a second. And Okay, so I'm going to share my screen with you at this point in time so we can go ahead and look at some IXL together. All right, so these were some of the questions that you had some trouble with when you were working on IXL DD4 last week. So I just want to go over this with you. It says 34 guitarists attended a jazz camp along with 44 other young musicians. It wants to know what is the probability that a randomly chosen musician is a guitarist. So the first thing I'm looking for is guitarist, which is going to be 34. And now what you need to think about is how many total musicians are there. So you have 34 that are guitarists, and you have 44 other young musicians. So you need to add these two numbers together. So 34 plus 44 is going to give you 78. And again, IXL will accept your answer if you are in simplest form, but it will also accept your answer if you are not in simplest form. So I'm going to go ahead and submit that, and I have that answer correct. We have a six-sided die here with a probability of less than 3. So if we think about it, the numbers that are less than 3 are 2 and 1, and so that'd be 2 out of 6, which simplifies to lowest terms of 1/3. So prime numbers. You will get to a question where it asks about what a prime number is. A prime number is any number that is divisible only by itself and the number 1. So my prime number in my spinner here is the number 7. So there's only 1 out of 3. And then you will get questions with an entire table. Carmen recorded how many nuts of each type were in a can of mixed nuts. What's the probability that a randomly selected nut will be an almond? So find almond here, which is 28. And then you need to know how many total are in the can. So I need to go ahead and grab my calculator. 31 plus 28 plus 4 plus 17. And I have an answer of 80. And again, if you want to reduce that fraction to lowest terms, you can. If you want to just type it in as 28 over 80, they will accept that too. So those are the questions from IXL that I know some of you will have some difficulty with. I hope by me going over these with you that it helps you out. And we will continue and learn more about theoretical probability tomorrow. So I hope you all have a great day, and I will talk to you tomorrow.